Hello everyone. In this video, we are going to dive into an important part of working with data manipulation. This includes how we import data, store it, clean it, and export it for analysis. Let's begin with the ETL process, a critical framework in data engineering and analytics. ETL stands for extract, transform, and load. These are the three main steps we follow to move and prepare data for analysis. So, what is ETL exactly? It's a pipeline that takes data from different sources and brings it into a central location, like a data warehouse or data lake, where we can analyze it. Let's look at each step. Extract. This is the first step. We pull data from various sources, like databases such as MySQL or Oracle, flat files like CSVs and Excel, or cloud platforms like AWS or Google Cloud. The goal here is to gather all relevant data without affecting the original systems. It's important to automate this step and handle different formats. Transform. This is where the real work happens. In this step, we clean and validate the raw data and convert it into a usable format. That might involve removing duplicates, converting data types, joining tables, or filtering out unwanted records. This step ensures our data is high quality and consistent. Load. Finally, we load the transformed data into a target system, like a data warehouse or data lake, where it's ready for use. We can do a full load, everything at once, or an incremental load, just the new or changed data. ETL is crucial because it lets us combine data from multiple sources, clean it up, and make it usable for reporting, dashboards, and machine learning. Now that we know how data gets to us, let's talk about the tools we use to work with it. There are many data manipulation tools, and the right one depends on your goals and your data. First up is SQL. SQL, or Structured Query Language, is used to interact with relational databases. It's great for selecting, filtering, and joining tables. A basic SQL query might look like select columns from table where condition. It's simple and very powerful. Next is RR is designed for statistical computing and is popular in research and academia. It's great for data wrangling and analysis, especially with packages like dplyr and tidyverse. R works well with data frames and has excellent tools for visualization and modeling. Python is a general-purpose language, but it's also one of the most popular tools for data science. The Pandas library makes it easy to manipulate datasets, while NumPy is useful for numerical analysis. And finally, Excel. Excel is still widely used in business for quick analysis. With Power Query, Excel can handle more advanced tasks, like connecting to external data sources and cleaning up messy spreadsheets. Each of these tools has its strengths. SQL is fast and efficient for querying large datasets directly from a database. It's intuitive and widely used in business. R is great for statistical analysis and visual exploration. It's ideal if you're doing research or working on predictive modeling. Python is extremely versatile. It's perfect for building data pipelines, automating tasks, and integrating machine learning into your workflow. Excel, especially with Power Query, is easy to use, requires no programming, and is perfect for smaller tasks or quick reports. So, which tool should you use? Use SQL when working with structured databases, use R for statistics, heavy analysis, use Python for automation and large-scale data projects. Use Excel for accessible, quick work, especially if others need to view the output. Now, let's talk about data formats. When sharing or importing data, the format matters. It helps others and systems understand what the data means. Simple text files often use formats like fixed width or delimited. Fixed width files have specific character lengths for each column. This makes reading very fast but limits flexibility. If someone's name is too long, it gets cut off. Delimited files like CSVs use commas or other characters to separate values. These are more flexible and common, especially for sharing between different tools. We also use markup languages like XML, HTML, and JSON to structure data. These are especially useful for web data and system-to-system communication. Let's start with the fixed-width file format. In this format, each column has a set number of characters, so the start and end of each field are always in the same position across rows. There are no separators like commas or tabs, just plain text aligned by position. Take the top figure, for example. It shows 3 columns with widths of 8, 12, and 7 characters. That means each row must follow that exact layout. This format is very consistent, which makes it efficient for computers to read, especially with large datasets. But there's a trade-off. Column widths must be defined ahead of time. If a name column is 8 characters wide and a name is longer than that, it will get cut off, also called truncation. Now let's talk about delimited formats. These use special characters, commonly commas, to separate values. That's where we get the term CSV, or comma-separated values. Look at the bottom figure. Each value is separated by a comma, which tells the computer where one field ends and the next begins. Delimited files allow for variable length fields, so names or other values can be as long as needed without being cut off. And while commas are the most common delimiter, others like tabs or semicolons can be used too, depending on the system. So how do they compare? Fixed-width files are more rigid and structured. They're fast to read when the layout is known, but can be less flexible. Delimited files are more adaptable. They work well with modern tools like Excel, Python, or R, and are easier to share and edit. The choice depends on your needs. Fixed width is good for speed and structure, while delimited is better for flexibility and compatibility. Let's take a look at XML, which stands for Extensible Markup Language. It's a widely used format for representing structured data and is often used to share information between programs, systems, and people. XML uses markup tags to define the structure of data. Each data item is wrapped in a pair of tags. For instance, a phone number might look like this: opening tag, telephone 419-528-915, closing tag, telephone. The opening and closing tags clearly mark where the data begins and ends. XML is case sensitive, meaning lowercase telephone and capitalized telephone are not the same. One advantage of XML is that users can define their own tags as long as they're meaningful and clear, like name, age, or email. The format is designed to be easy to read for both humans and machines, which makes it great for sharing data without losing context. But a downside is that XML files tend to be larger due to all the tags, which can slow down downloading and processing. Even so, XML remains a popular choice when structure and clarity are important. Now let's talk about HTML, or Hypertext Markup Language. Just like XML, HTML is also a markup language that uses tags to define and structure data. But here's the key difference. XML tells us what the data means, while HTML tells a web browser how to display that data. In HTML, tags like table, tr, and td are used to organize and display content, like tables, headings, and paragraphs on a web page. For example, the tag table marks the start of a table, and tag/table marks the end. One important difference from XML is that HTML uses standardized tags, which are set by groups like the World Wide Web Consortium. That means users can't just make up their own tags in HTML like they can in XML. Web browsers, such as Google Chrome or Safari, are built to understand these HTML tags. For instance, tag th is always read as a table heading. In the example shown, we have a table with 3 columns: name, telephone, and salary. Each row is defined with a tr tag, and each cell in a row uses td tag. Also, unlike XML, HTML is not case sensitive. That means lowercase table and capitalized table will be interpreted the same way by browsers. So in short, HTML focuses on presentation, while XML focuses on meaning and structure. The next one is JSON, which stands for JavaScript Object Notation. JSON has become a very popular format for data sharing, especially as the idea of open data has grown in recent years. Originally, JSON was based on JavaScript syntax, but today it's a universal data format supported by many programming languages, including C, Java, Python, and more. In the figure shown here, you can see an example of how data is written in JSON. Like XML, JSON is human-readable and self-explanatory. But JSON comes with some important advantages over XML. First, JSON is much less verbose. It doesn't use as many tags or labels, which means smaller file sizes, a big benefit when working with large data sets. Second, JSON supports a wider range of data types, including arrays and nested structures, which are harder to represent in XML. Third, parsing JSON, meaning reading and processing the data, is generally faster and uses fewer computer resources compared to XML. Because of these advantages, JSON has become a standard choice for data exchange, especially in web and mobile applications. Whenever you move data from one system to another, there's a risk that some data could get lost or corrupted during extraction. This is why data validation is critical. Validation ensures that the data you plan to analyze is complete, accurate, and consistent with the original source. Data validation involves checking that no data was lost or altered during extraction, and it helps catch errors early. Here are 4 key steps to validate your data after extraction. Compare record counts. Check that the number of records you extracted matches the number in the original source. If numbers don't match, some data might be missing. Compare descriptive statistics. Calculate statistics like minimum, maximum, and averages for numerical fields in both datasets. This helps confirm that the numbers make sense and nothing was cut off. Validate date-time fields. Dates sometimes get misinterpreted as numbers, especially in tools like Excel. Check that dates fall within expected ranges and are formatted correctly. Check text field limits. Some systems limit the length of text fields. Verify that no text was truncated during extraction by comparing maximum string lengths. Validating your data this way ensures a solid foundation for analysis and reduces surprises down the line. After validation, the next step is data cleaning. This is the process of finding and fixing errors, inconsistencies, or missing values in your dataset. Cleaning makes your data more accurate, complete, and reliable. Why is data cleaning important? It improves data quality, so your analysis reflects reality. It prevents misleading results that happen when faulty data skews conclusions. It enhances model performance because machine learning and statistical models work better with clean data. It builds trust in your findings when sharing results with stakeholders or decision makers. In short, clean data is essential for trustworthy and actionable insights. Data cleaning usually follows 3 main steps. Identify missing values, find gaps or blanks in your data. Ensure consistency. Make sure data is uniform across fields and data sets. No conflicting formats or categories. Facilitate automation. Structure your cleaning so it can be repeated easily or integrated into automated workflows. Following these steps helps maintain clean data over time, especially in larger or ongoing projects. There are several common techniques used to clean data, including handling null or missing values, removing or replacing special characters, trimming whitespace, fixing inconsistent formatting, removing duplicates. Let's dive into each of these techniques in more detail. Missing data can happen for many reasons. Maybe data wasn't collected or a value isn't applicable. Missing values show up either as empty cells or as special placeholders like null. Why do missing values matter? Because they can cause errors or bias your analysis. Common ways to handle missing data include dropping rows or columns with too many missing values. This is simple, but can reduce your dataset size and hurt your analysis if you lose too much data. Imputation, where missing values are replaced with estimates. For numbers, you might use the mean or median. For categories, the mode. More advanced methods use interpolation or predictive models. Imputation is generally better than dropping data because it keeps your sample size intact and can reduce bias. Special characters are non-alphanumeric symbols that sometimes sneak into your data. Examples include punctuation like %, $sign, control character like tabs, line breaks, or hidden control characters. They often come from manual data entry, web scraping, copying and pasting, or merging datasets. Special characters can cause big problems in data processing or analysis. Common cleaning steps include removing irrelevant symbols like currency signs, replacing characters such as turning dashes into nothing or spaces, stripping out HTML or XML tags when importing web data, cleaning hidden characters like non-breaking spaces or smart quotes. These steps help make your data clean and consistent for analysis. Whitespace refers to spaces before, after, or between words and characters that are invisible but can affect your data. Extra spaces often appear due to manual entry errors, copying from different sources, or merging data. Trimming whitespace means removing these unwanted spaces to ensure consistency. Common practices include removing spaces at the start or end of text fields, replacing multiple spaces between words with a single space. Trimming whitespace is a simple but important step that prevents bugs and errors in later analysis. Inconsistent formatting means the same kind of data is represented in different ways. For example, different capitalization, capital New York versus lowercase New York, date formats, month, day, year versus year, month, day, numeric precision, 1.00 versus 1, abbreviations, US versus United States. These inconsistencies can cause problems when grouping, matching, or summarizing data. Fixing formatting improves accurate grouping and filtering, correct merging or joining of datasets, reliable visualizations, and statistics. To avoid issues, define and follow standard formatting rules, automate formatting during data import, use validation checks, and perform early data profiling. Duplicates are records that appear more than once in your dataset, either exactly the same or nearly identical. They can result from merging files, manual entry, system errors, or data integration. Duplicates can inflate counts and averages, skew model results, lead to misleading insights. Removing duplicates helps keep your data accurate and trustworthy. Most data tools have built-in functions for detecting and removing duplicates, but always review duplicates carefully to avoid deleting valid data.